Yesterday we talked about this Terraform introduction and then what challenges we usually get without using this Terraform and all, right? And also we saw about this Terraform architecture. And then comes to Terraform installations. Okay, and as part of that, right, like whatever code we write as part of Terraform, so we recommend using this Visual Studio Code so that if there are any syntax issues, and we also install some extensions on Visual Studio Code so that Visual Studio Code will help us how to write code effectively, right? It will also give us some help and all. So everybody must install Terraform and also Visual Studio Code, right? So that we can write Terraform code. And I also ask everyone to install this AWS CLI. As part of this, we configure AWS CLI. It is like an authentication between your laptop and your AWS account. So that whatever code we write, right, this code will be executed against your AWS account. Okay, and right. Okay, this we did not cover. Okay, from here we have to start. Terraform core concepts and Terraform lifecycle commands. Okay, there are hardly some 4 to 5 Terraform lifecycle commands. Okay, no matter what code you write, and these are like standard commands. Okay, and these are the commands which we will be running it whenever we wanted to provision an infra. Okay, so like the very first command what we supposed to run was init. Okay, Terraform init, right? So whenever you run this Terraform init, the command, okay, let me create. This is the folder which I created. Okay, let me rewrite everything whatever I have written, right? Let me take Visual Studio Code. KodeCraft Terraform training. Okay. So if you look at here, yesterday I created a folder on my desktop and I created a main.tf file. Let me remove this file, main.tf file. Okay. And let us build it new. Okay. I will show you again how to write that main.tf file. As of now, just think of it. Okay. You have created an empty folder onto your desktop. And then the same folder I have opened using Visual Studio Code. Okay. Just install Visual Studio Code and open folder. So this is where whatever folder you wanted to open, select that folder and this folder will get opened here. And since this folder is empty folder, there are no files and folders inside it. Okay, if you wanted to create files inside this, so this is where you need to click on it. If you wanted to create folders inside this folder, so you can click here and then you can give the folder name and all. For now, I wanted to create a Terraform file. Okay, so let me click on this new file. Okay, I'm going to give, file name can be given any name, but extension must be .tf. So all Terraform files like must have an extension .tf file. Okay, this is a prerequisite. So the moment you put .tf file as the extension, since I have installed this HashiCorp extensions, here, right, HashiCorp Terraform extension, automatically, right, your Visual Studio Code identifies this is a Terraform file. Okay, and inside that, whatever content we write, like based on what you write, the respective services will get provisioned in your AWS account. As I said, the provider block is the must. With the help of provider only, your Terraform will get to know in which cloud provider you want, right? Your services will get provisioned, right? To get this Terraform provider block, right? We go to terraform.io document, official documentation, go to this registry and browse providers. As I said, right, these are the different providers which will be supported by your Terraform. And based on which cloud provider you wanted to provision your resources. Let's say if I wanted to provision any resources in Azure cloud, just click this Azure and right, this is the code which you're supposed to copy, like here provider Azure RM, and this is like your provider version, okay, 3.110.0. So this is the code if at all you wanted to provision services in your Azure accounts. Okay, since here we are going to provision server, any services in AWS account, here we have to click on this AWS. So this is where, right, again, this block of code is optional, but this is a mandatory. Okay, if you don't specify this Terraform provider version block, automatically the latest version which will get downloaded by default, right? If at all you don't want this latest version, and if you wanted to download the previous version, like this is actually plugin version. Okay, you can just choose the previous versions. If the moment you choose this previous versions, automatically, right, here you can just verify like 5.55.0, which is what I selected here. If you don't specify this particular block, automatically this latest version of the plugins will get downloaded. Okay, again, like this is an optional, but this is the mandatory one. Okay, provider, based on this provider, whatever the code we write, that code will run against this particular cloud. Okay, let me copy everything, put it here. So this is a provider block. Inside this provider block, there are few arguments which we supposed to pass. Okay, and normally, right, whenever we wanted to provision, we usually select a region. Okay, and if I go back here, just click this documentation. If you look at here under provider, we normally give this region as the argument. Okay, so this US-East one is the right North Virginia region code. Okay, let me put it different region code. Let's say AP-Southeast-1, which is Singapore region code. Okay, this is provider block. This is how we need to write provider block. From now on, if you wanted to provision any services in AWS account, everything will be treated as a resource block. Okay, so let's say I wanted to provision an EC2 server. Okay, so if you look at here under this AWS provider, these are the resources supported by your like Terraform. Okay, these are the different services belongs to this AWS cloud. So if we come down all the way, so here we have Elastic Cloud Compute. Okay, EC2. So that means EC2 is a like virtual server. Okay, it is an instance. So under EC2, you will have two sections. One is resource section, and you will have data source sections. Okay, this data source sections I will talk little later, probably in next few classes. But now let us just worry about this, like understanding these resource blocks for this EC2 instance. Inside this resource EC2, you will have many resources. Like, so if you wanted to create an AMI image, normally we logging into this AWS account. So that is where we will be selecting like create an image option. So where we create Amazon mission image. So if we wanted to create same image using Terraform, so this is the resource which you supposed to select, right? Everything, right? So here AWS AMI is a resource. So that means we have to write resource block, resource, and what type of resource. This is actually resource type. Okay, type must be like these are the supported types by this EC2 as the resource. We cannot give any other names here. We have to write based on what we wanted to create. The respective resource type have to be specified here, and this name can be anything. And these are the supported arguments. Okay, and if I come down all the way, so let me talk about this AWS underscore instance here. Right? If you wanted to provision an EC2 instance, right, this is the block you have to select. Resource, inside resource type, and this name can be anything, and AMI. Okay, here you need to give AMI ID of like what AMI ID this particular EC2 instance will be used to provision. And right? Instance type, because these two are the mandatory arguments. Without you are passing this AMI image and then instance type, you cannot provision your EC2 instances. Okay. If we come down all the way, like, right, this particular resource will support multiple arguments. Okay. You have to remember these are the arguments. Okay. How do we write this one? Resource type, and this name can be anything. And it actually starts flower bracket here, and flower bracket ends here. And inside this, you have to write the like kind of arguments. If you wanted to know further, like what are the supported arguments, what are the mandatory arguments, and what are the optional arguments, either you can just scroll down all the way to down, or you can click here, argument reference. Okay, so when you click this argument reference, it will directly take you to the bottom of this page where this particular resource, okay, the resource type is like AWS underscore instance. Whatever arguments supported by this resource, all will be documented here. So from here, you can just read it and you can understand like what are the optional arguments. If you look at here, right, associate public IP address, it is an optional. Okay, so AMI is what I say is mandatory, but here if you read this one, optional. Okay, when it is optional, when you specify a launch template, because right during our AWS learnings, we have created launch templates. So as part of launch templates creation, we have specified that AMI ID, like AMI, and also instance type. So what it says, whenever you specify launch template, then you don't have to pass this AMI ID. If you don't specify this launch template, AMI is a mandatory. The same way, if you look at here, right, availability zone, it says optional. So that means what it means, like if you don't specify this availability zone, it is like this particular instance, like whatever we are going to provision this instance, we'll go ahead and then provision in any of the availability zones. That is clear, right? That we also checked it during, okay, let me show here. See, you all have to be very strong in basics. So that is where I'm just emphasizing a lot on the basics. If I select this EC2 as a service, so launch instance. So yeah, this is like instance name. You can give any name. So as I said, this is the mandatory image. Image is the mandatory one. Without this, we cannot provision EC2. And instance type. If I come down little, okay, this is instance type is again a mandatory one. And this availability zones, right? So this is where like we usually edit this network settings. So this is where we usually select like in which subnet, based on in which subnet, like based on what subnet you choose. Based on that, this particular server will get launched in any of these availability zones. If you select this particular subnet, your instance will get provisioned inside this availability zone, AP-Southeast-1A. Again, this is an optional argument. That is what here, right? If I go to this reference of like argument references, availability zones, it is an optional. No, if your requirement is like you wanted to build this particular instance on some particular availability zone, so this as the argument which you need to add it, okay, inside this section. Okay, so here like this list will go on, like whatever supported arguments are present in the below. So you, based on your use cases, based on your need, you can add those arguments over here and you can change the values for those arguments. But for now, let me just have this particular code. So what this
All
code
the
does,
arguments should be under resource group only.
see these arguments, right? Yeah, all the arguments, when you say here, this is one instance, right? See this particular resource, like EC2 will support few arguments, and these are the arguments. If I choose some other resource type here, AWS underscore key pair, it will support different arguments. Let me.
Yeah, okay, yeah, understood that.
Understood, right?
But yeah, for EC2, everything should come under resources,
Right,
right?
right. So in this case, right, this particular resource will support different arguments based on its
That's cool.
characteristics, right?
Yeah, yeah.
Okay. So like whatever arguments supported for this instance, they all will be present in the bottom. Based on your use case, you have to write those arguments over here. Okay. And if you look at here S3 as the document, S3 as the resource, inside this S3, it may support different arguments related to your S3 bucket characteristics. Clear?
Yeah, yeah.
Okay. Now let me take this one. Okay. So here, right, this is where we have to write these resource blocks. Okay. Here AMI, it says data.ami. Okay. This I will talk later. For now, let us hardcode the value. So AMI should be like, what is that AMI? If you go to this AWS account, like if at all I wanted to provision an EC2 server with Ubuntu image, this is the AMI ID. Just copy this AMI ID and put it here. Okay, instance type, let me just provision with T2 dot, right? So this is how you need to construct your Terraform files. Okay, provider block is mandatory one, which will specify in which provider you wanted to provision resources, and again on which region you wanted to provision. In this case, AP-Southeast-1 means, right? If you look at here, AP-Southeast-1 means we are going to provision an EC2 server inside this Singapore region, and what resource we are going to provision. Okay, AWS underscore instance is nothing but an EC2 instance. Okay, with this AMI ID, and this is the type of instance. Okay, this is how we need to write. Okay, and this is like everything. I'm just writing it inside this main.tf file, and this is where we will be running it. Right, once you have constructed this kind of Terraform files, you need to apply these lifecycle commands. Okay, right. What this Terraform format does, there is one command like Terraform FMT. Right, usually people who are aware like AML language, AML is like kind of indentation language. If we specify here like this, in AML, it actually treats some different meaning. But here, like, even if you write code like this, it will still work, because as I said, like Terraform is like uses HashiCorp configuration language, which does not have any indentation and all. Okay, even if you give one argument here and one argument with after few spaces, it will still work. But for when it comes to readability perspective, like it won't be nice. So for that, what we can do it, when I run this Terraform FMT command, I mean all the things will be aligned in the same order, so that, right, it is better readability. Okay, right. So for that only, it is just a format. Okay, nothing with respect to any technical here. And Terraform validate. So, right, as I said, right, whenever we write these kind of Terraform codes, because it is a kind of code, we may make some kind of mistakes, like, right, missing these codes or missing these flower brackets or anything. So in this case, right, I wantedly deleted these codes and also wantedly deleted this closing curly braces. Okay, let me save it. Right. So whenever I run this Terraform validate command, it actually validates the configuration what you have written. Okay, so that means the configuration file should not have any syntactical issues. Right. In this case, as we know that, okay, I wantedly make, right, deleted this codes. It will tell us like, okay, where the syntax issues are done. So this is where it will show me like, okay, so the codes like invalid multi-string, all these things. Let me put it back. Okay, here there is one extra code. Okay, all this, right? Now the code looks good. Now when I run this Terraform validate command, it will just validate missing. Okay, in order to run this Terraform validate command, the very first command what we supposed to run was Terraform init. Okay, this is the first command which we supposed to run. Okay, it says right while running this Terraform validate, it says like you need to run this Terraform init. Okay, so we need to initialize this folder Terraform init. So if you look at here, right, as of now we have written only one file, main.tf file. As part of this Terraform init command, it initializes the current working directory and it downloads these plugins. Okay, right? It actually creates .terraform folder. Inside this .terraform folders, it actually downloads the Terraform, like whatever, right? Based on this particular block, it actually downloads some plugins, right, which are necessary for executing or creating this infrastructure and all. But ideally, we don't make any changes in this, like in Linux, right? If it is a hidden folder, it will be starting with dot and then folder name. So the moment you run this Terraform init command, it actually creates a .terraform folder, and inside this folder, all the provider plugins gets downloaded. But we generally don't go inside this .terraform folder and make any manual changes. So this is the first command which we supposed to run. Okay, and after that, right, now you can run this Terraform validate command. So what this command does, like it actually verifies any syntactical issues against your .tf files. Okay, now if you look at here success, the configuration is valid. So that means this particular .terraform file does not have any syntactical issues. Okay, if there are any syntactical issues, obviously when you are trying to create infra using this configuration, your infrastructure will not get provision. So it is a best practice, like we run this Terraform validate and to make sure like whatever code we have written, it does not have any syntactical issues and all. Okay, and this command as a mandatory step, right? The next command is like Terraform plan. So what this command does, whenever we run this Terraform plan, it will just give us the plan, okay, and what resources are going to provision. So in this case, we have written a resource block only for one resource. Okay, let me run this Terraform plan. Okay. So if you look at this plan output, right, Terraform will perform the following actions. Okay, this is the instance name, AWS_instance.web, and this is the AMI, and whatever AMI you have specified here, right? Let me, okay. So whatever AMI you have specified here, 4DFA, right? Even your plan will all say, right? Your plan will read this configuration file, and it will tell us like what is that resource is going to provision and with whatever arguments you have specified here. So in this case, this is the AMI. Like if it's whenever you see this plus means it is actually addition. Okay, so that means the new one resource is going to create. And if I come down little down, there are few things, right? If you see like disable API stop and EBS optimized, all these things will be known only after creation of an EC2 instance, right? But there are few things which will be known even before creation of an EC2 instance. In this case, right, since we have specified instance type, right, t2.micro, which is what we can see here. And right, this we don't need to create any server to see like what type of instance is going to create. So right, if you wanted to know like what are the resources are going to provision as part of this, so we need to run this Terraform plan command, which will tell us like what resources are going to provision. And then the next command is like Terraform apply. So whenever you run this Terraform apply, it reads this configuration file and then apply onto your AWS account. Okay. Now let me show you here again. If I go to AWS account, if I go to instances, okay. If you look at here, I don't have any instances here. I'm in Singapore region. Now let me, right, as we know, right, based on this configuration, it has to provision one EC2 instance inside this Singapore region, like, and the instance tags will be like hello world. Now let me apply Terraform apply. If you look at here, like, so whenever we run just Terraform apply, it is asking our confirmation. Okay, here we have to type yes, right? Only yes will be, it is like an acceptance. The moment I put yes, like, it is actually creating. Like, you can see that instance is getting created, like creating. Let me go to AWS account and then be in Singapore region and then refresh. Can I check? The tag name, what I specified for this instance is hello world. And this is the instance which is getting provision with the help of Terraform code, right? You can check here, right? Resource one is added. Is this clear so far? Any doubts?
Yes, clear.
Okay.
It's clear.
So this plan command will just give you like what resources are going to provision. That's all. Okay. It does not do any action. But whenever you run this apply command, only then the instances will, only then the resources will get provision. Okay. Right. Like before performing any actions, if you wanted to like kind of dry run, okay, the plan is the command to see what resources are going to provision. So whenever you run this apply command, it actually, right, creates whatever resources you have specified here. Okay. So, right, and after that, we can run this command, Terraform destroy command. So what this destroy command does, it actually terminates this instance. Okay, it actually deletes this instance. Okay, but if at all we want like whatever resources you have provisioned using Terraform, okay, if you wanted to delete these instances, so Terraform destroy is the command which we had to run. But as I said right yesterday, Terraform is like idempotent. So when I say idempotent, so no matter how many number of times you run, it actually gives us the same output. Okay, now again, let me apply it. So if I apply again, will it create one more resource? I mean, what is your understanding on it?
No, it won't create. Actually, as I said, it is idempotent. It will check whether it same instance is already created or not. It is already, it won't execute again.
Okay, the reason being, right, why it won't create new instance when I create Terraform, when I run this Terraform apply again, right? The moment I run this Terraform apply command, see, you can check it, terraform.tf state file which got generated here. See, we only created this main.tf file, and as part of this Terraform init command, .terraform folder got created. And after we apply this, like the moment we run this Terraform apply command, like it created one resource. In addition to that, this terraform.tf state file got generated. Okay, this we did not create. This is created by Terraform itself after this particular command run. Okay, so that means what this state command, state file, as it like this particular state file tracks the information about the servers, like whatever server, right? In this case, the server is provisioned in AP Southeast-1B. So that means, like as part of this Terraform apply command, one server got provision in our AWS account. That server information is already recorded here. Okay, unless you make any changes to this configuration file, it won't create new server. Okay, now let me try to apply again. Let us see actually what. See here, right? 0 added. So that means since that server is already present, hence it won't create new servers. Now, like, right, we create some server, no, we create few servers and then we make certain changes, right? Now let me add, right, instead of t2.micro, maybe, right? Otherwise, let me change the tag. Okay, hello world to make it. So in this case, right, as I said earlier, right, as part of this architecture. So in this case, right, so this is the configuration file which we have written, okay, main.tf file. And we also have now Terraform state file. If you don't have Terraform state file, initially, right, when you just build main.tf file, and if you are not run any Terraform apply command, so you'll have only main.tf file. When you have only main.tf file, so this core will not have this Terraform state file, okay? It just takes the input of this configuration files and then apply based on whatever you had defined, whatever resources you had defined, the respective services will get provision in your cloud providers. But in this case, we already have Terraform state file. And because this Terraform state file got generated when you applied, right, when you apply this configuration. So that means using Terraform apply, you apply that configuration. Again, if you run this, actually, right, your core will take your configuration as input and it actually compares your state file. Okay, if both are matching, it does not create any new resources, right? In this case, right, I am just modifying the tag allow world to. So whenever I change the like kind of tag for this, so that means I am changing the tag for the existing instance itself. Okay, now if I apply Terraform apply, right, when I run this Terraform apply, if it should not ask us that I know, like kind of yes, right, it asks us yes, right, you can run this command -auto -approve, so that, right, it will not ask us like again press y yes, like for the confirmation. Okay, spelling mistake. Terraform apply -auto -approve. So when I specify this -auto -approve, it won't ask our user input again, press yes or no. So in this case, if you look at this one, right, nothing has been added. Okay, 0 to add means no resources have been added, and then 1 to change. So that means you can also check like what has been changed. This till symbol represents like the changing the values. The earlier value was hello world. It has been changed to hello world -2, right? So in this case, it will clearly tell me like, okay, this is the tag has been changed on this particular resource. So like this, based on whatever values you change here, based on that, it will show you like you can also run this Terraform plan command, which will again show you the similar output. Okay, as part of this plan command, it actually reads your configuration file and also compares your state file, and then it will tell us like what are the changes. Right now, let me go because I have applied. I ran this Terraform apply command here. Now let me go to AWS and then refresh. Can you check? Can we change the AMI ID? Is it possible?
No, until and unless we change the reason, we will not be changing the AMI ID.
Or else we have to delete and recreate this one, I guess.
No, we can change the AMI ID, right? But instead of Ubuntu this version, it may go to a different version of Ubuntu or different AMI.
So normally, right, since we learned AWS in last 2 weeks, when we spent almost 2 weeks time for right on the same instance, can we change the AMI ID?
No, same. I mean, you mean to say running instance?
Yeah, running in. I mean, be it running
Whatever
instance or
running
yeah,
and stop
yeah.
instance, we
Yes,
will
doesn't
not be
matter.
changing
Doesn't
the
matter.
AMI ID of
delete
instance. We cannot.
We have to terminate and then only we can create it.
Correct. So,
Terminate.
right, it is like kind of AWS limitation. We cannot change the AMI ID for the running instance. Okay, even if not only running instance, even if you shut down also, you cannot change it. Altogether, you need to create new instance. So normally, right, if I change the AMI ID here, it actually creates, let us change this AMI ID, right? In this case, right, this is just a tag. Tags can be changed. See, there are few things which can change it, okay? But there are few things, if at all you wanted to change few values, sometimes, right, you need to shut down. But AMI ID is something like, right, which cannot change it, okay? You need to create new instance altogether. Now let me take new AMI ID here and then update it. So let me take new AMI ID here. So this time, right, instead of Ubuntu, let me take Amazon Linux. And let me take the AMI ID of this one. And then update here. Which is C64E. C64E. Now, if I apply Terraform, if I do Terraform up,
You simply will get a different instance.
different
That's
instance, correct. Yeah, it actually terminates the existing one. It actually terminates the existing one.
Correct.
So what I mean to say, like, there are few characteristics we can change it on fly, and there are few things which we cannot change it. That's what I'm trying to say. Okay, if
Why, I have one question here. See, tags names are just like namesaking. We can give it XYZ also. But
correct.
here it has to create new instance, but old one it has to be there present, right? Exist.
This
How
is
it
old
will
one
be
only. For tags will be applied on the existing instance itself. If you look at here, this is the existing instance. Okay, this did not create new instance. On the
So this
existing
will
instance,
remain same, right? It will be
yeah,
existing.
this is not,
It will
see,
create with one more new instance with the same name.
no. This was the existing instance initially created, hello world. As part of this tag change,
It's
this
just like name
it just,
changing in the host.
tag changed. See, right, let's say let me add one more tag. So usually, right, tags you can see here. If you go to this particular instance, this is where you can see the tag value. In this case, right, I can add one more tag here. Okay, name equal to, maybe department equal to some DevOps. Okay. Now let me let me just apply Terraform. Okay. Before applying, I just modified this one as well. I wanted to put it back.
If you change the instance, then it will be a
It
different
will,
instance,
yeah,
right?
it considered as a new
instance altogether. Yeah.
So yeah.
Whenever you are changing a AMI
Yeah.
ID.
So I just put it back, this AMI value, and then instance type. Now this case, right, this time what I have added one more department equal to DevOps is department. Now if I apply this one, Terraform apply -auto -approve. So that means one more tag will get added to the same instance. It does not create new instance for this. So right, you can also plus means it actually adds, right, one to change. Now if I go and tags section and then refresh, can you check department, like DevOps is a department like this. Clear everyone so far?
So,
Yeah.
usually if we change the instance ID, it will create a different instance, right? Here, instance ID is the primary of creating the instance, basically.
Instance ID, right? Here instance ID is different. Instance ID, like whenever you create an instance, an ID gets generated. AMI ID is different. AMI ID is like your OS image ID.
Understood.
Okay, this is the AMI ID. If we change this AMI ID, then it will create new instance altogether.
Okay, but with the same name, hello world 2.
Yeah, it depends actually what tags you specify here. Based on what tags you specify here, based on that, your new instance will have the respective tags.
Okay.
If I
And
just change here, if I just change the AMI ID, yeah, you'll get new instance with these tags.
okay, fine. Accidentally, this main.tf file is deleted. I have terraform.tf state file. So can I get back the main.tf file?
So you have only Terraform state file.
Yes.
Cannot. This is cannot, but we have alternate solutions for that, right? Like before Terraform, you might have provisioned these servers manually. Just think of it, okay? You don't have Terraform as of now implemented in your organization. You may have provisioned few servers manually like this, okay? But you can bring this server inside this, right? Inside this Terraform state file, okay? So for that, like we usually use a Terraform import command, which I will show like how the demonstration and all in the feature classes, like how to bring this manually provisioned servers inside your Terraform. Like it has to be tracked. See,
Okay.
right? Since this server is provisioned using Terraform, like we cannot just from now on, right? We cannot just manage this server manually. Like we cannot, right? Like what we can do so far, I can just stop this instance and then I can change this instance type from t2.micro to t3. Like any other larger instance type. But if you look at your Terraform configuration file, it is still your old instance type. So right, whenever you apply, this will get overwritten. So from now on, if at all you wanted to make like all the managing stuff should has to be done through your Terraform only.
Okay.
Okay, and right. So any resources which you wanted to provision, you have to write resource block and then resource type and then logical name. And then these are the like supported arguments and then the tags. Let me. Okay, I have my GitHub repository. I will just walk you through a few things. If I go to my GitHub account, so I have Terraform training. Terraform training is the repository where I generally write all the Terraform codes, right? So if I go to this EC2 folder, so this is what we just demo, okay? Single EC2 instance, okay? If you look at this ec2.tf file, this is the code exactly what we have written by taking this code from the AWS documentation, okay? This Terraform block and then provider block, and then specify the region code on which, based on this region code, this resource will get provisioned here, and resource, and what is the resource? Okay, this is clear. Now, right, how do we provision multiple instances? Okay, I'll just walk you through this code. So this provider block is a must block for every code. And if you look at here, right, here we have to use some kind of variables. Okay, let me go to Terraform variables. Terraform variables. Okay, before this, right, if we are writing these Terraform codes like this, it is not a good practice actually, because we cannot hard code. Let's say today I have spin up an instance, maybe with web 1. Tomorrow I wanted to create maybe DB server. So what I had to do, I had to have complete code, and maybe, right, I can have one more folder here, like DB server. Inside this DB server folder, I need to have main.tf file. And again here, I need to copy everything. And then change this tag from hello world to DB server. So, right, initially I had just think of it, okay, this is the code I have written for our web servers. And tomorrow we may get request for provisioning DB servers. So, right, it is just only one thing, like AMI ID remains same and instance type remains same, and only the tag value will change from web server to DB server. So what we have to do, everything we have to copy, right? It is like we are duplicating this code from web server to DB server. Okay, ideally this is not a best practice, right? Keeping the same code in multiple places for provisioning, like let's say assume that okay, we have 100 servers, and if we wanted to change the instance type for all 100 servers, so that means we have to go to every folder and then change this instance type. Okay, which is not right. We have to write the Terraform code effectively. Okay, like kind of better reusability and all. So this is not a best practice, like having the same code duplicated across different folders and all. Like we had to write kind of variabilize this code. Okay, how do we variabilize this one again? Go to main.tf file, right? So the way how we write these resource blocks, we write this variable block. Okay, variable block. What is that variable? So I wanted to variable this instance type. Okay, or maybe AMI. Okay, so this is the variable name, and what is the default value? So default value, I can have this one, right? Let me cut and then put it here. So in this case, right, if you write resource blocks like this with everything is hard-coded value, every time to change these values, we have to come here and then change the values. So instead of this, var.ami, right? So we have to write this variable blocks, variable, and then this name can be anything again. But whatever name you give here, this AMI value has to be passed to this AMI argument. So var.ami. So how it is like, this is how we have to declare the variables, and this is how we have to call the variables. Okay, variable block is the block variable and then variable name, and what is the default value. Okay, again, this is an optional, right? Okay, this is the default value, AMI ID. Now I wanted to variabilize this instance type also. I don't wanted this to be hard-coded. Again, variable instance type default equal to, maybe, right, I can put it as t2.large. Again, we had declared this instance type variable, and how do we call? var.instance underscore type. Don't give here double quotations here. So double quotations is where we just pass this kind of strings. But while you are using these variables, you have to give like var.ami. Instance type will be var. Like this is where, like, how do we declare, and this is how do we call var.instance type. So that means when I run this Terraform apply command, based on what variables values you have declared here, these values will be coming over here. So in this case, right, I have not changed the AMI ID. I just copied from here and then put it here. But when it comes to instance type, earlier it was like some other instance type. Now I have put different instance type. Okay, now let me save this file. Now, if I run Terraform plan command, so within plan command itself, we'll get to know, like, okay, any changes. So that means 1 to change. Let us see what is getting changed. Right? See, earlier it was like t2.micro, and it is changing with t2.large. So that means whatever values you have defined inside this variable block, which is getting read here. Clear?
Yeah,
Yes.
but what is the use of doing this way? I mean, at this point in time, I
Hmm.
did not see any difference because we are not giving anything from outside, right?
No, it is not about giving from outside. We had to write Terraform code effectively, right? We should not be hard coding
Correct.
any values here. Hence, we
But here
define
we hard-coded variable values, right?
where here.
Yeah, in the default.
So
Yeah.
normally what we do, I mean, is this clear? Then I will tell you even better way of writing this code.
Oh, okay. Yeah, this is clear.
This is
Thank you.
clear, right? So normally, right, what we do in real time, what we do, right? We will need to use multiple blocks. Like similarly, provider block. See, provider block will have its own significance. And similarly, we also write resource blocks. Similarly, we will also have like data blocks, variable blocks, and all, like output blocks. There are different blocks. I will be explaining, and we will go through every block. Okay. All the variables, right? What we do, we don't define these variable blocks inside same main.tf file. Rather, what we do, we create a variable.tf file. Okay, not here. Okay, if people are getting confused here, let me delete this DB server. Okay, now, right, again, let me show you here for the people who get confused. Let me refresh here. This is the folder where I am working on it currently. So main.tf file is the initial one which I created. This .terraform folder got created as part of Terraform init, and Terraform.tf state file got generated when I applied Terraform apply command. As you make multiple, right, when you run multiple apply commands, like it always takes this backup of your Terraform state file, because Terraform.state file is critical file, okay, which maintains one copy backup. Even for some reason, if we lose this Terraform state file, like it is difficult to track the servers which we provision. Okay, now what I will do, instead of keeping all the blocks here itself, we will be writing a variable block here. Okay, variables file.tf file. Like, just think of it. Okay, now I don't write anything here. Any variable blocks I don't write here. Rather, what I will do, variable AMI default, right? This one. Now, what I will do going forward, right? If at all I wanted to make any changes, every time I'll just come here and then change it. I don't have to make any changes in this file. Is this clear, Ravi?
Yeah, it makes sense.
Yeah,
But
correct.
how do
Right?
we call this variable.tf? From where
Same,
will you call?
same way. See, you,
Yeah.
within this, I mean, we don't have to follow any other different approaches. So we have to
in
have
main.tf, we need to call this, right? Somewhere we need to define this, right?
here, and inside this variables.tf file, I have declared the variables. This is
Understood.
clear. Okay.
Yeah.
If I go to main.tf file, you just use the same values, var.ami. It just picks
Okay.
because whenever you run this Terraform apply or plan command, it not only reads single file, it reads all the files.
Oh, okay. Got you.
Okay,
Yeah,
it
got
reads all the files, and it actually takes all the values whenever it needed.
Got you. Thank
Okay,
you.
so
Yeah.
if we follow this approach, right, going forward, if at all we wanted to make any changes, we don't have to make any changes in the main.tf file. Rather, we make changes in the variables.tf file, and whatever values you pass here, based on that, the respective resources will get provisioned.
Got it.
Okay, now, right, now as of now, I have showed only a variable with some string value. Okay, like this default values and all. Let me talk more about these variables, like Terraform variables, like input variables. Okay, so if you look at this documentation, like, see, like type of variables, even if you look at my documentation, okay, this is done. Let me, okay, variables, output blocks. Okay, variables are necessary to parameterize our deployments in Terraform. That means, right, it is not a best practice to hard code any values within our main.tf files and all. Right, input variables allows us to pass configuration values at the time of like deployments. So what it means, like, so in this case, right, we have given these values here, AMI value or the instance type and all. Now what I will do, like, let me not give this one. Okay, I will just delete it. So that means I have defined a variable like this, but I have not passed any value. Okay, before that, if I go over here, see, these are the arguments. Again, the way how we will have arguments for resource blocks, even for the variable block also, variable and then variable name. Again, these are like arguments. If you look at here, again, arguments. What are the supported arguments? For this variable block is, again, you have to little come down. Like these are the supported arguments. Default. So that is where like default is one of the argument for your variable block. Hence, I have given default. Okay. And if you look at here, default, it is an optional. Like these are the supported arguments: default, type, description, validation, sensitive, all these things. Again, all these are an optional. There is no argument as mandatory here, like kind of required argument. Okay, I can delete. Okay, I don't want it to delete. Okay, so in this case, right, I had defined a variable like instance type for which no arguments are mandatory as per Terraform documentation. Okay, now let me run this. Let me apply this configuration. Terraform apply -auto -approve means
But instance type is missing
where
in that variable.tf file.
variables.tf file.
Instance type is missing, default value.
Yeah. I mean, I purposefully made this one.
Oh, okay.
So what I mean to say, if we don't give default values, see, right, these are default values. Whatever values you specify here, these values will get loaded here. Okay. Just think of it. Okay. You had defined a variable and you have not passed any default value. Okay. I purposefully deleted this default value here.
Okay.
Okay. Now if I run Terraform plan, see, var.instance type. That means we have not passed any default value. It is asking my user input here. Got it? var.instance type, which is this one. var.instance type.
That is going to be my next question. You already answered it now.
Okay. Normally, right, I come step-by-step approach so that you all will be like, right, you can correlate the things. That is how I usually go. Right? Now you can put it as t3.large. This is like instance type. Based on what value, right? If you don't specify these default values, right? Like whatever you pass the values during your runtime, you can check, right? Earlier, the instance type was this one. Like this is the instance type which we have provisioned during runtime, like which we have passed during runtime. Clear? Right? Again, this AMI ID also, you can just delete it. Like whatever, if you don't specify any default variables here, it will ask during runtime. Okay. Now in this case, right, Terraform plan. Okay, if I run this one, it asks user input. So I don't want this to ask during user input, right, during runtime. So normally, right, if at all we wanted to do this one automation way, so if we say automation, it should not ask user input. So for that, what we will do, var equal to instance type equal to t3.large. So that means, like, this is the variable. Okay, you can also check the syntax here. So what it says here, right? If we have not defined any default values, and like even though if you have defined default variables, how do we override those values? While you are applying our plan command, Terraform plan -var equal to, this is just single variable, okay? And this is the variable name, image_id, and they're just giving whatever. So in this case, right, I have not used any, like I have not passed any values. So I wanted to pass the value for this instance type. So for that, Terraform plan -var equal to, like -var equal to, like variable name and then the value of the variable, like instance type equal to maybe, right, let me put it whatever instance, like maybe, right, M3 or whatever it is. So this time it won't ask my user input during runtime. Is it clear? This is another scenario.
Okay. Clear.
Is everyone following, or is it difficult?
Yes, following.
Follow.
Okay, it is like if we don't specify default values, it asks our user input. But if it should not ask user input means you have to pass those variables like this, -var equal to variable name and then the value of it. Okay, so in this case, right, I'm just having only one variable. So we can just simply pass like this, Terraform plan -var. Just think of it, okay, you may have multiple variables where you need to pass the values for multiple values. So you can continue to do like this, -var equal to maybe like AMI equal to AMI ID, something like this. You can continue to pass like this, but just think of it, okay, you may have 100 variables, right? It is difficult, or it's right, it is difficult to do like this 100 variables. So what we can do in that case, we can have a file. Okay, again, var-file. So that means we can create a file like this, testing.tfvars. Okay, let us do this one. Okay. Now what I will do, I will create a different file here, like dev.tfvars. So where I will AMI equal to, so I wanted to put this one, AMI equal to, and what is the value? Now let us not have this default. Okay, you can also, it is just like, right, if you just put it like this, you can also put like this. Okay, so this variable and then the variable name does not have anything. Okay, you can define like this. That means I have defined two variables. Since I have defined two variables, I had to declare like this, var.ami and then var.instance type. But inside this dev.tfvars file, AMI equal to AMI value, like this we have to define instance underscore type equal to like t2.micro. Now, right, if we follow this approach, Terraform plan -var file equal to dev.tfvars. So that means if we have multiple variables defined on a, like here in this case, the extension should be .tfvars. So that means it is like all the variables you are declaring under this kind of extension file, .tfvars files. -var -file equal to, if we specify like this, now it treats all the variables from this file. Like, because I have given the same values, which is already exist on the existing server, it did not change. Let's say, right, it shows no changes. Like, right. So here they have given like testing.tfvars file, but doesn't matter. Like, it is like, right, just think of it, okay, you may have few servers in your dev environment, or you may have few servers in EVT environment. The only difference from your dev environment to your production environment is that your production servers will have the bigger capacity. When it comes to your dev servers, it will have just on, maybe just think of it, maybe 2 CPUs or 6 GB. When it comes to production environment, it may have some maybe bigger instance, like maybe 6 GB or 20 CPUs and all. So, right, we cannot write like this kind of code duplicatedly. Rather, what we do, we will have like this file one time, and then we create multiple, like for your dev environment, we define all the variables like based on your dev environment capacity, like your in terms of AMI, instance type, etc. And let me create one more file here, prod.tfvars. So what I will do, let me copy these values. Let me go to prod.tfvars. In this case, right, I can have that am5.large. Okay, am5.large. So that means whenever I run this Terraform plan command, when I pass this vars, right? Again, no, we usually create different folders while we are provisioning different environments. So whenever we apply this prod.tf vars files, it should give us the bigger instance because m5.large is the bigger instance. And when I give this dev.tf vars files, like this will provision just t2.micro instance, whereas the main code we don't have to duplicate. Okay, this code we write only once. Is it making sense?
Yes, yes.
Yes, sir.
Is it difficult for for any of you?
No, we are good.
No.
How about others? Because I keep getting replies only from few folks who are getting it. Ashwini, are you clear?
Yes, sir. It means main.tf file once it created, different dev branches are different files we are generated like this.
Yeah. So main.tf file we write only once. Like
Yes,
because we have to reuse this code. How do we reuse this code for multiple environments? We write these variables files based on our different environments. If you write dev.tf vars with certain variables, and when you apply, so you will have one dev server which is provisioned based on this capacity. And when you provision prod.tf vars files, like, so it will provision one more instance, like with whatever values you specified here.
Can you show us a variable.tf file once? And this is also mandate, right? For us,
Yeah,
it is
this
not
is mandate.
required.
This is mandate. See, whenever you specify like this, var.ami,
Okay.
variable block has to be defined.
Okay.
The moment, right? If you don't define a variable block, let me just write. If I go to this variable block, either I will comment it, or I remove this entire thing. And when I run this Terraform apply or plan command, it will tell you a message that, okay, you have declared a variable, but which is not right
Available.
defined, something like that. Okay,
Yeah.
you have used and which is not declared. Okay, that is a mandatory step. So whatever variables you are referencing with like var.ami, the respective variable block has to be defined it. But these are optional things. The arguments for your variable block is optional thing. Okay. Now again, yeah.
One question here, like whatever the variables we defined here, is it limited to this folder, or can we call it from any other project? Like say we have another folder where we have a main.tf. Can we use the variables from there also? Can we call the variables?
No, actually, right, to use this one or can call from any other projects, that is altogether modules. Okay, modules is again a different topic, and which is important topic in Terraform. Probably I will be talking it after 2 days, the modules concept, where I can tell you like how do we reuse these variables, which are defined it on one place, how they can be called in other projects.
Okay, got
Okay,
it.
that is, but right, whatever you defined here, right, because all these things we are defining in the same folder, right, and we are not passing any single file here. So whenever you apply Terraform plan or init, right, or apply commands, Terraform will read all the files and it takes the action against all these files.
Correct.
Okay.
Okay.
So when I talk about this modules concept, where you can understand even better, like how do we organize even better way. But for now, everybody has to understand like how do we define variables, how do we call, like what are the different types of variables and all. But for now, I have not talked about the variables, different types and all. Right? Since you are all aware, like now, like when I say type, so default is nothing but the default value for the variable. Okay, input variables. Okay, here, right? So variable image name type equal to like, so we can have string type. So in this case, right, if I look at here, this is string type. So that means AMI equal to like this string. Okay, it is just since it is a string, we are enclosing in double quotes. So right, normally right, we can also have variables of type integer. So right, we might need to present some 5 EC2 instances. So that means count equal to 5. So that means when you use this as the argument, based on what number you specify here, based on that you can provision 5 EC2 instances. So that means that variable types can be multiple things. One is like string variable, and you can also variable of list. When I say list, this particular variable can hold multiple values. So obviously, right, available zones will have many, right? So in each region, available zones, at least we will have 3 or maybe more than 3 also. So if that is the case, we will be defining a variable and availability zones, and right. So default equal to, if it is a list, it should start with this square bracket. Okay, here they have just given only one, but we can also add multiple values. So that means if it is a string, directly we pass like this, like this. If it is like the string value, like availability zones. Okay, and how do we call? This is how we call AP-southeast-1A, comma, AP-southeast-1B. So this is like the least variable. So that means this particular variable will hold multiple values. But in this case, this particular variable will hold only one value. But in this case, this particular variable will hold multiple values. This we call it as list or kind of array. Okay, array is nothing but it actually holds multiple values. Okay, here the list of string. Okay, here this is one string, and it can have multiple strings also. And we will also have like kind of objects. So what this object is like, right? This particular variable will have multiple values. Okay, and the use case for this, right? Here we will have multiple regions, and this AMI values will differ from region to region. Let's say I don't want it to, right? If I go here, so whenever I change this region name, in this case, right, the AMI what I defined here, this AMI value is valid as long as I don't change this region name. If I change this region name from AP Southeast-1 to some other region, this AMI is invalid. Okay, so let me show you what it means. If I go to this Singapore region and if I select launch instance here, so if I select this Ubuntu image, so this is the AMI ID, okay, 4DFA. But if I change this Singapore region to, just remember 4DFA, if I change to any other region, okay, here even if you select the same Ubuntu image, it will give us different, right? Let me select Ubuntu image. It will give us different AMI ID. See, earlier it was like 4DFA, now it is giving us like 21C4. So that means what I'm trying to select, right? These AMI IDs will vary from OS to OS and also from region to region. Okay, so with this approach, right, while we are defining this provider block, the region is a mandatory argument. The moment you change this region from AP-Southeast to any other region, this AMI ID is invalid. Okay, it won't, right? Even if you give like this, it will give an error that AMI is not valid, something like that. But right, we can have it, we can declare one variable like region specific. Okay, we can define one variable of type map. Okay, and here, right, AMI equal to like this region specific. Okay, and I will show you that example also. It will be there in my GitHub somewhere. So what you have to understand for now is that, okay, variables are of different types. Okay, string and numbers and also Boolean. Okay, So Boolean is nothing but it actually accepts either true or false. Okay, the use case for that is like we can have instance either public IP assigned or not public IP assigned. So if that is the case, we can define a variable of type Boolean. We can just give true or false. Okay, like these are different variables types. You can just read this document and can understand even, right? As you come down, you can also see many examples, right? So like this is like AMI ID. Since this is a string, you can give like you can also give the description. You can also have some kind of validations. Let me go down a little way somewhere I can. Okay, this is resource. Okay, this is how you have to call AMI equal to var.image ID. Okay, this we have this also we have seen like how do we create this kind of .tf files and how do we pass those files. See, what I'm trying to say, like you have to read this documentation carefully so that right you'll have very full grip on your Terraform, right? In this case, right, you can see right, image ID is like a string, okay, and in this case, if you look at here, availability zones, right, availability zones can have multiple availability zones present in each region. So in this case, availability zone like the square bracket, and this is one availability zone, this is another availability zone. I just wanted to show you like, okay, and all these things we have covered, right? So here, right, we can also define environmental variables, okay? So environmental variables is nothing but for your environment, let's say, right? In case of Windows also, I can define environmental variables and I can use those environmental variables also, okay? How do we define those environmental variables is like tf_var, and on top of that, this image underscore ID, okay? Based on what image, so that means like you can define same variables in multiple places. You can define variables in variables.tf file. You can also define variables in like this kind of files, dev.tf files. And you can also create one more file like terraform.tf file. So right, if we define variables like this, okay, let me copy these values and then put it here. So let me go to dev. Let me go to this dev.tf file. Now, if I run this Terraform plan, right? So Terraform plan will read this terraform.tf files. Okay, here, right? We don't have to explicitly specify like var -file. Okay, so it actually reads all the values even from this file. Okay, this is like whenever you define variables inside this terraform.tf files, you don't have to explicitly specify again like prod.tf or dev.tf. It actually picks the values from this file automatically. See, I mean, it is getting I mean, it will not ask us like based on what values you have given. See, inside this terraform.tf files, I have specified m5.large. I think here also, if I little go up, I should be able to see that m5.large. See, m5.large. Because right, when you specify or when you declare variables inside terraform.tf files, you don't have to pass explicitly again this file. Okay. And right, you can define these variables in multiple places, but there is a precedence, right? If we are defining different values for the same variable in multiple places, there are some precedences. Let me go down. Okay, let me, I have also documented here. Okay, so variables are of different types here: string, number, Boolean, list, map. string visa AMI ID or instance type, number is equal to, as I said, count equal to, and Boolean, it actually accepts either true or false values. And least means this variable can accept multiple values. Map, as I said, when you create a key pair kind of thing, like if it is Singapore region, accept this as the AMI ID. If it is North Virginia region, accept this image ID. So if you have a requirement to do that kind of automation, so we usually declare a variable of type map and then can give it, right? And if there are any sensitive variables, so we specify sensitive equal to true, like the like database passwords and all. So if we are declaring like it's RDS, right? While we were provisioning this RDS instance, so we used to enter database password. So if we wanted to provision same RDS instance using Terraform, so we had to write resource block for your RDS instance, where we also create variables for your database passwords and all. So while you are declaring these variables, so we usually specify sensitive equal to true. That means whenever we run this Terraform plan or apply commands, this password will be hashed out. Okay, so right in Windows, like how do we export this kind of, how do we create environmental variables, all these things, right? So when, right, as I said, right, we can also declare variables in environmental variables. You can also define variables in terraform.tf files, which I just shown like this. And you can also have like dev.tf files or production.tf files or see, whenever you have files like .auto.tf or terraform.tf files, these files will get loaded automatically. We don't have to explicitly specify these files. And if we have defined files with any other names like dev.tf files, those has to be explicitly called using -var-file. And if you have a single variable which needs to pass, then you have to give -var. Okay.
So suppose if we have .auto .tf-vars and Terraform .tf-vars, which one will take the precedence?
So if you look at here, right, always the last one, right? From
Okay.
here, the higher precedence will go to the ones which I defined the bottom. So here, right, there are how many? There are almost five different places. Environmental variables, terraform.tf files. See, you read this sentence. Terraform loads variables in the following order, with later sources taking precedence over earlier ones. The later means this is the last one. So that means if we are declaring a variable in terraform.tf files, these values can be overwritten using -var or -var files. Like, see, whatever values you here, these will be overwritten with these values. Okay, that means this is the latest, this is the higher precedence compared to here.
Thank you.
Okay, this output block I will cover tomorrow. Yeah, any questions so far? Is it? Yeah.
Because suppose we have created a couple of servers from this folder, right? It has the state, everything is exist. If suppose I got another 10 servers to build, I usually create a new folder and I execute it.
No, normally, right, if it is same project, see, it's up to your use case, whether it is the same project where you are going to create new 10 servers, or if it is a new project, because, right, this Terraform.state file is very important. If you lose this Terraform state file, it is as good as you cannot track any of the servers which you provision.
Exactly.
Okay, if it is a different project, it is recommended to create different folder altogether and create this kind of configuration files and then run this Terraform apply commands.
Okay.
If it is the same project and you wanted to enhance it, then, right, like you will have like again within the same project you will have multiple environments, your dev environment, your UAT environment, again you'll have production environment. Again, for all these things, we will have different folder structure altogether. We will have different folder structure. Probably, right. I have those things are already in plan. Okay. Probably in next 2 days, you'll understand like how do we organize the code and all. See, as of now, right, whatever code we are writing it, this is not the way how we write in real time.
Correct.
But I am giving you all the basics, like how do you, like all like variables declaration, how do you call like these variables, like various ways where you can not declare all these variables, like what are the precedents, all these things. But as we go in the next sessions, I will tell you even how, right, how in real time, how these codes are being written in effective way.
Okay.
Like, as I said, the modularized way, and then the folder structure. Okay. And how do we manage this Terraform state file? Because, right, as of now, we are storing this Terraform state file locally. Okay. Normally, we don't store Terraform state file locally. It's a best practice because, right, let's say today I have spin up this EC2 instance. Okay, tomorrow I go on leave and I will ask somebody, like I'll ask somebody to assign some disk. Okay, right? Those guys needed to have this configuration file along with state file. Only then they can add disks to this existing existing server. So that means, right, while I'm going on leave, I need to pass this Terraform state file and also I need to pass this existing configuration files. Only then they can add further things. Okay, so normally, right, it is like an exchange, and we don't exchange this Terraform state file. So rather what we do, we store this Terraform state file in S3 bucket. Okay, and which will have access to all your all your team members. Okay, anybody if they wanted to, right? Again, this main.tf file, all these files, we will be checking into GitHub. Okay, we don't store, like we build the code, we write the code, and we test it. Okay, once this testing is done, we will just copy all this code into version controls like GitHub. And this Terraform state file, we will be storing it in S3. I have a dedicated classes, okay, just for one hour plus, just to talk about the state file. Like this is so important topic. Okay, you'll get to, you'll know actually everything in next few days. But for now, right, whatever I'm just teaching you, you just learn it. This is kind of like the good foundation. Probably in next few days, all the things will be answered, like how do we manage this state file effectively? How can we provision different environments based on what values, modularizing everything. I'll be doing it in next 2 days or 3 days. Okay. Okay, if no questions, I'm done actually.